Good day. This is part 3 of the pre-recorded video lesson on transformations of function. And for this video, we are going to talk about dilations. So when we say dilations, it is a form of a non-rigid transformation, meaning the graph of our functions are distorted. A dilation can be classified as either a stretch or a compression. And here there are two types of dilations. It can be horizontal dilation or vertical dilation. And under each type, so meron pa rin tayong further classification. So for example, in horizontal dilation, it can be reclassified as horizontal stretch or horizontal compression. Similarly, for vertical dilation, meron din tayong vertical stretch and vertical compression. So let's talk about first horizontal dilations. So let's say we have here a parent function, f of x is equal to x cubed, represented by the green graph. And here we have two transformations. We have the red graph representing the quantity 2x cubed. And for the blue one, we have here the quantity 1/2 x raised to the third power. So as you can see, the transformed functions is of this form, f of b of x, b times x. Therefore, with a scale factor of 1 over b, and that scale factor is parallel to the x-axis, we can say that the graph compresses if b is greater than 1, and if b is within 0 to 1, or that's a fraction, then the graph stretches. Okay? So here, in these three functions presented on your screens, with the green one being the parent function, so for g of x, our b here is equal to 2, and 2 is greater than 1, therefore, the graph compresses horizontally. Okay, so ang ibig sabihin yan, if this is the parent function, the green one, so i-compress natin siya horizontally. So upon compressing the function horizontally, then we will arrive at this red graph. And for the blue one, our b here is 1/2, and 1/2 is greater than 0 but less than 1. Therefore, we expect that the graph is stretched. So again, starting from our green parent function, we stretch horizontally the graph, resulting to the blue one. Okay, so take note of the direction of our compression and stretching. So it should be parallel to the x-axis, meaning horizontal. Okay? For the vertical dilation, so referring to the three graphs shown on your screen, whereas the f of x is equal to the absolute value of x is our parent function, the green graph. And we have here two transformed functions, the red and the blue. For the red one, that is 3 times the absolute value of x. So essentially, this is 3 times your original parent function. And for the blue graph, it is 1/3 times absolute value of x, or that is 1/3 times your parent function. So if there is a factor or a multiplier a outside of your function, such that we have this form, then we can say that the scale factor is a, and our dilation direction is parallel to the y-axis or vertical. Okay? So if the value of a is greater than 1, the graph experiences a vertical stretch. And if a is from 0 to 1, then the graph experiences vertical compression. So meaning G here experiences a vertical stretch. So it is stretched vertically with a scale factor of 3. Okay, so again, illustrate that, we start with the green parent function. So if we want to stretch this vertically, so take note of the direction of my stretch. Okay? So kumbaga, ine-elongate natin yung ating parent function in the y direction. Kaya siya naging ganito. Okay? And if we want to compress the function vertically, okay, so take note of the change in direction. So pag ganito. So we are compressing it. Therefore, we arrive at the blue graph. Okay? So what happens to the domain and range of dilated functions? So in general, for vertical dilation, the domain of transformed functions remain the same, whereas the range may vary. Okay, so it may or may not be affected by vertical dilation. On the other hand, for horizontal dilation, the domain may be affected, whereas the range is not affected, or it remains the same. Exercises for this type of transformation. Item number 1, describe how the graph of G is obtained from the graph of F. So again, these F functions right here are your parent functions. Okay? So for item A, since the multiplier is outside of the function, then this experience what? What type? Again, if we go back to this slide, so this is of this form, a times f of x, wherein your a is 1/4. Okay? A is equal to 1/4. 1/4 is less than 1. Therefore, this is vertical compression. Okay? For item B, so from absolute value of x plus 1 to this form, and as you can see, our multiplier inside the absolute value sign or symbol is square root of 2. So B is equal to square root of 2, and square root of 2 is greater than 1. Therefore, this is horizontal. So again, let us go back to the previous slide. B is greater than 1, therefore it is a horizontal compression. So horizontal compression. And the scale factor, take note, we need to get the reciprocal of this. So the scale factor is 1 over square root of 2. Okay? For item C, so if this is the original and this is the transform, then we can say that we have here a variable b, which is equal to 0.25, or this is 1/4. Okay? So 1/4 is less than 1, therefore this is horizontal stretch. Okay? And the horizontal stretch with a scale factor of the reciprocal of 1/4 is 4. Okay? And for the last item, this is your original, this is your transformed. So essentially, we have here 4 times the absolute of x plus 1. So yung multiplier natin na 4 ay nasa labas. Therefore, a is equal to 4. And a is greater than 1. Therefore, this is vertical stretch. So if there is vertical dilation, then the scale factor is automatically the value of a. So no need to get the reciprocal. Okay? So here are the summary of rules for transforming functions. Okay, so in general, if all transformations are present in your function, then from our simple parent function that looks like this one, it can transform into this form. So y is equal to a f of b times x minus c plus d. wherein your A, B, C, and D represent your different types of transformation. So again, for letter A, variable A, so that is for vertical dilation. If A is greater than 1, then that is vertical stretch. If A is less than 1, that is vertical compression. And take note, scale factor is A itself. Okay? If A is negative, okay, then we have a reflection about the x-axis. Next, the B variable represents horizontal dilation. So if B is greater than 1, that is horizontal compression. If B is from 0 to 1, that is horizontal stretch. And take note that the scale factor to be used is the reciprocal, 1 over B. And if B is a negative number, then we have a reflection about the y-axis. And inside your function, if x is being replaced by x plus c or x minus c, then we have a horizontal shift. So shifting to the left if x plus c, and shifting to the right if we have x minus c. And outside your function, if we have here a plus or minus d, then the function experiences a vertical shift. Plus d means we are shifting upwards, minus d means we are shifting downwards. Okay? So if all transformations are present in one function, then in order for us to get the accurate graph of that transformation, we need to follow a certain order. Okay? So just remember, happy dogs run vigorously. So our mnemonics for that is HDRV. So mauuna ang horizontal translation, followed by dilation, followed by reflection, and then last one yung vertical translation. Okay? So exercises, if we want to combine different types of transformation. Number 1, explain the sequence of transformations applied to our parent function f of x to obtain g of x. Okay, so again, our big picture is this one. So a times f of b times x plus minus c plus d. Okay, a vertical dilation, b horizontal dilation, c horizontal translation, and d vertical translation. And if may positive negative ka dito sa A and B, then it can be reflection over X or over Y axis. Okay? So let's identify the variables A, B, C, and D sa ating G of X. Okay, so I have here A, which is equal to negative 1. This is negative, less than 0. Then, therefore, this is what? Based on the big picture earlier, we have a reflection about the x-axis. So we have a reflection about x-axis. What else? I have here a c. Okay? So x minus 2, meaning we have a horizontal translation. Is this to the left or to the right? So since we have here x minus c, then we need to shift it to the right. Okay, horizontal translation 2 units to the right. Okay, and we have here plus 5. Okay, so D is equal to plus 5 greater than 0. Therefore, this is vertical translation 5 units upward. Okay, so meron tayong tatlong types of transformation present here. So the first one, reflection about x-axis. Second one, horizontal translation. And last one is the vertical translation. Item 2, explain the sequence of transformations applied to this parent function to obtain this transformed function. Okay? So A is equal to 3, yung nasa labas, and this is greater than 1. So if A is greater than 1, okay, we have here a vertical stretch. So this is vertical stretch. Scale factor is equal to 3. Okay? What else do we have? We have here a B, which is negative 1. Ito siya. B is negative number. Therefore, we have a reflection about the y-axis. Okay? What else do we have? We have here an x plus 1. So we have here x plus c. Therefore, this is horizontal translation 1 unit to the left because we have here plus. Okay? And lastly, d is equal to negative 2 less than 0. Therefore, this is vertical translation 2 units downward. Okay? So overall, there are 1, 2, 3, 4 types of transformation. So again, in order for us to identify those type of transformation, we need to look at the big picture, which is this one. Okay, so we need to identify the variables A, B, C, and D respectively. Okay, so this ends our topic on transformation of functions.